Welcome to the video tutorial of how to assemble a HPD F1 version 2.0. I have here the printed parts that is going to be assembled for a colleague in the club that is joining us and driving F1. I have prepared the pieces with taking away the support materials, and I have been checking that all or at least most of the screws are going to be possible to put in, and it's the usual problem of holes not always getting as they were expected to be. The real cradle I have printed in PETG, and in the hope that it will withstand the temperatures of the motors and still be as durable as the PLA Plus or Prima Select that we have been using previously. For the car, we have two different kinds of motors here in our local series, and well, strictly we have one, but it's allowed to use a few others that are in competing series, and the one that is allowed is this one, and it has the mountings of the cables on the rear. This is making it very difficult to get it in here, which means that I will try to find a solution for this for the future. It is possible to get it in, but I'm not certain that I can get the cables there. So an upgrade on the cradle is probably coming in the nearest months. For the time being, I'm allowed to compete with this one, and this one is working just fine to put in. You have to put the motor before you are assembling the rear damper mount, because you can't take it out through the bottom. It's simply too small space there. So first of all, we want to assemble the rear axle and the new differential. The new differential is made up with a new component. Instead of an O-ring, which has been very good because O-rings are standardized and you can get the exact dimensions and features everywhere. This is maybe a little bit harder to find. It's a gasket for hoses, like Gardena, I guess, and maybe in taps and similar. It's a G20, also called a 3/4 inch gasket. The trick here is that they have different thickness, and in this case I have designed it after a 2 millimeter thick gasket, readily available in from well, let's see if we can have a bag laying around. Yes, here we have. It is Gelia G20. This is bought from a company named Clas Ohlson, which is well known in Sweden, Denmark, Finland, Norway, maybe somewhere else also, I don't know. It is possible to buy them on different shops also in Sweden, but there are also other alternatives which doesn't work. These are simply too thick. Still intended for the same purpose, but will not work. So if you have problems in your country, please make a note either in below this video or in the forum we have on Google+, and maybe somebody else can find a way to arrange it. maybe sending it to you by post. Anyhow, the reason I'm using this gasket now is that it has proven to be working much better. It is giving a shorter flex distance, and it has a bigger surface towards the diff washer, which makes that it simply works much better. When assembling this, you can get a very smooth action from it that rivals the ones from for instance from X-Ray, which is my favorite otherwise. The differential washers I'm using here is Serpent. I'm also using X-Rays, or if you can get the Hobby King version, or any other version really, because the outer diameter seems to be the same on all, and the inner diameter doesn't matter. All the diff washers are the same thickness as far as I've seen. We have also experimented with using standard washers for 14mm screws, and it works, but it is a little bit more gritty in the action, and it is also wearing down pretty fast. Meanwhile, these are they don't seem to wear at all. So it's my choice is to buy these, a little bit more expensive, but it's less maintenance. So we add the ball bearings also, and there it escaped. So when you assemble this and you don't get it, I don't know if it's visible here, if you don't get it correct, that the things are going into their position, it will work rather poorly. But just hold it like this and turn it around a little bit, and sooner or later it will move into space. I think into place. I think that did it. Okay. Then we need to have the actual bearings here. Axial bearing, outer, the actual balls, and oops, wrong way. So right way down. So, and a lock nut. Tighten it a little bit. I want to have something on the bottom to hold it while screwing. So, and then we tighten it as much as we feel like. If you have very good grip on your circuit, you can tighten hard to get better acceleration, and so if you have a slippery circuit, you can have it so that it is slipping. Just be careful that it doesn't slip too much, because it is plastic against plastic, and the friction will make the axle to melt. So that seems to be as good as we want it. So assembling it into the cradle, put in the ball bearings. For me they fit perfectly. For some others it might be too loose. The measurement is that it should actually be a play, but when I'm printing it in my printer, it is shrinking so that, well, it fits perfectly. So if you have a good printer, it will be a play here, and then you can take a screw here and tighten so that you don't have any play in the ball bearing. Be careful not to tighten too much, because then you will deform the ball bearing and it will be a gritty movement. A small play is maybe not so bad. So if it works without, that's great. So rear wheel on. Well, I haven't tightened it completely, but it doesn't matter for this showing. Okay, we want to have the damper mount for the rear damper. We should have the motor in here, of course, because you can't put the motor in after we have assembled this one. But as this, if this is not going to be delivered with the motor, so I'm going to assemble it as it is. Observe that this is a countersunk screw. It's 1 out of 3 countersunk screws, and this is because it needs to this one is otherwise touching the inner side of the body when the car is rolling in a corner or over a curb or whatever you're doing. So the main chassis, we have nuts to put into place here. So, and we have these 5.8 millimeters balls that are supposed to fit into this place on the rear and the cradle. Seems like I have some grit there. That the printout isn't perfect. Should see if we can take it away. So yes, that's much better. So put the nut back. And screw it in place. These nuts are bought from Hobby King. It's Trackstar. Any other brand will be, of course, good enough. Or you could 3D print the ball and use an ordinary screw holding it in place. That's up to you. So this is the way we want to have it. Put it upside down, and we add the arms that are going to hold it on place. Right and left, so we don't get rear wheel steering here. Oh, that's the wrong way. As you might see here, there's a flat space on one side, not on the other. This is for having as a spring seat on the side springs that are mounted later. Not in this video though, as I don't have the pieces at the moment. So, and then we are putting this in place there. As you see, I'm taking rather long screws to have a lot of material to hold it. You choose how long screws you want to have, but I recommend a little bit longer ones. So maybe you want to see. So if you tighten this too much, it will be very hard to move it, so we open it up. Here's a potential for improvement. If you want to have, you can have ball ends instead of these plastic ones. That was the plan. This was just to be there for the time being, but it has proven to work so well, so I haven't actually replaced it on any of my cars yet. And the question is if I ever will. Ball ends will last longer and probably hold better also. But this is sort of a part that can break instead of some bigger one, and they are fairly quick to print, so I actually really like this solution. These screws used for the clamp around the pivot ball should be the right length, not too long, not too short, just exactly as long as they should be, which is something like 7 millimeters, 6 to 8 I would say. If they're too long, they will start sticking up here, and they will be in the way for the motor when you want to move it forward. So not too long here. And fun fact, it's in Swedish we have a word named lagom, which means exactly what I said. Not too much, not too little, just exactly as much as it should be. So maybe something you should try to get into your language, whichever language you're speaking. So we have assembled the rear. It's a little bit friction now, I can feel. Can open up a little bit on this clamp, actually, so slightly better. The friction doesn't matter that much because we want to have damping, and that's not the optimal damping, but it will just add a little bit to what we have here. Of course it will maybe confuse when you want to have the same as somebody else and they have different friction in the suspension. It will mess things up. I'm using 450 oil in this Trackstar damper, which is 48.5 millimeters. Don't ask me why it's 0.5. It is working fairly well. I'm really impressed by these dampers. Once again, you don't need to buy these dampers. You can buy those parts from wherever you want, or take something that you already have. But these are really nice, and you buy 2 of them for 10 euros, and well, they have been working really nice, and I do recommend them. Together with, again, 5.8 millimeter screws, or balls, sorry. It's M3 screws, of course. So the front end of the front damper mount is also used. I'm also putting a small hook here that is laid over like this, and it is for holding the cables on place, the cables going back to the motor. And I'm putting 2 of them, one on each side, so that can have sensor cable going around in a different way. This is of course up to you how you want to take your cables, how do you want to route them through the car. It's also your choice on how long screws you're using. I think I've made really deep holes on most of places where it's possible, so whatever you choose will work. So you can use short screws and get a lighter car, or long screws and be certain that they will not be drawn out when you put some force on it. So, and another ball. So, and we put the damper here. I prefer to put the damper this way. Then disadvantage with this is that the heavy part is on the part which is moving, which gives a bigger mass that is not under unsprung mass is the correct way of saying it. The advantage with this is that there's a slightly less sensitivity for air in the dampers, and as you know, air is getting into the dampers sooner or later, and with these cars you drive for a really long time. We drive almost 1 hour at the club. We have rather slippery, and therefore we can't push so hard, and therefore after a day's driving there's okay, I should do this the right way, it seems like. So after a day's driving there's bound to be some air into the in the damper, and with this it is slightly better. So we have assembled the rear one. I haven't put the wing on. Let's see here, but I think you can manage to do that without my help. So we want to have the front here. It is connected with 4 screws. So we take out 4 screws. See if they are okay. Different lengths. So try one, see how. Well, that seems to be a nice screw. Goes in appropriate distance. So then we need a nut, and I don't see any nuts here. Okay. Then we take a few new ones. So put it on place. Black is maybe, oh, we have already there. Black is maybe not so good on the video, but the guy that is going to drive this car we wanted it to be black and yellow. So here it is. So that seems to be a too short screw. Didn't reach to the nut. Now it doesn't want to go out. Well, that's tricky. That's annoying. So, then we take a longer one. Yes, this is better. So, and that's connected. And we take another one that is long. And there we have a long one. Oh, there. The material of choice that we are using, well, we haven't decided exactly which one we like better, but my choice is ESON PLA Plus, not ESON PLA, but PLA Plus, which I consider hold better. It is, even when it breaks, it keeps together, and the parts are not flying all over. The other that we like very much is the Prima Select, and Prima Select PLA, which is making really nice printouts, much better than the ESON PLA Plus. This is PLA Plus, and we have a car here that is Prima Select. And these parts, both are very, very good. They are actually withstanding a lot of crashes, and made this possible, I would say. Furthermore, when we now have this this added here, we should look at the nose cone. Here we have the nose. This is Prima Select Flex, actually. So I'm mixing different materials for different parts. This is soft. So when crashing into something, it's taking up some of the energy instead of braking. You see, you put the nose like this, and then you screw it on place here. And if you look at this, it is rather small, and it will easily be broken if you are using this in too hard material. So something soft here is really, really recommended. Otherwise, you might be without a nose. I've been using this Filoflex, which is a nightmare to print with the 3D printer with Bowden tube, which I have. Both my printers have, and it is possible, but it's really, really tricky. This was much simpler, but it's slightly on the hard side, which means that this might give too much forces on and actually break this connector. Well, we'll see about that. The wing adapter that we have here is also made, in this case, out of this Prima Select Flex, which was actually rather easy to print with compared to the others. And it is really stiff and nice, but still flexible, which means that it can take up the forces. If we take a wing, do we have a wing somewhere here? We should have a front wing. A kingdom for a front wing. Well, that looks bad. Well, there we have it. So when assembling the front wing here, it is able to flex a little bit and take up the forces without snapping off, like PLA usually is doing. So in a combination with tough PLA and a little bit forgiving material in the adapter between the chassis and the wing, makes that the wings are lasting, well, they are lasting really good. Of course they will break, and it has broken for me, but actually I haven't got into a situation where the wing have stopped working. What have happened is that pieces of the wing have broken, but the actual wing is still functioning as a wing, and I could complete the competitions, the heats. And that is a very important part, and something that we have spent a lot of time, me and my helpers in this project, to make it a strong and something that lasts, maybe not like the strongest F1 cars, but at least we're not getting out of the competition directly. The weak point at the moment is the rear end. Typically you hit something on the rear, and you might bend the rear axle, which happens on the other F1s also. But more commonly it's actually that the cradle is breaking, that it's splitting into two here. Because of the way it is printed, you have the weak point is the layer adhesion here. I have put some more material and strengthen up. It was one competition that I couldn't do the qualification, basically because I was sliding off on the straight and driving into the barrier, and it cracked here twice, which meant I had to start from last position in the finals. Worked better then, but it's still annoying when you can't drive. So I hope that this this PET-G we have in the rear here is going to improve the reliability too, but I'm not so certain. It seems like the layer adhesion in these in PET-G is not better than in PLA plus, and therefore it might actually be worse. But we need it for the temperature here. The motors are getting rather hot. Okay, we continue swiftly over to the front suspension here, where we are screwing this on place. Okay, maybe a little bit longer screws here, and it has got mixed up. And true to my myself, I have used different materials for everything. This is once again then Prima Select PLA, which is well, maybe it's not the best choice for these arms, even though it is a very good choice. I prefer to have the PLA Plus in this position. But it was supposed to be black, and I only have black in Prima Select. Okay, so now we have the front arm on place. Then we need to assemble a steering hub. It's a very simple construction with this thing, the steering hub. We need to have a axle for the wheel, which we take M4 times Oh, now I have to check so I don't say the wrong thing here. It is 25. M4 times 25. And screw it in. I only found one supplier in my town that had actually this, so it was really cheap though. But they were only in this, no hex drive here, and also the screws for assembling the front wing. Then of course was only in Phillips, so it means that suddenly I have 2 Phillips screws and hex everything else. Not so convenient when you're on the circuit. You need to have a Phillips 2 screwdriver just for 2 screws. But that will probably be a pulsing problem. They do exist anyhow. So there we are. Then we have the axle there. Of course, this is 4 millimeters, and the front wheel have a ball bearing with 5 millimeters in the diameter. So between the screw and the ball bearing, we'll put a small bushing. This is 4 times 5 millimeters. Well, 4 millimeter on the inside, 5 millimeters on the outside, and put it on like this, and then like magic. Of course, have it loose like this is maybe not optimum, so I'm using this hot glue, the glue pistol, and put it there so it sits on place. But we don't have to show you that. So for the suspension, the front suspension, we put in okay, this one was going a little bit too tough. So in this case, you take a 2 millimeter, wrong, a 3 millimeter, 3 millimeter. Oh yes, 3 millimeter drill, and drill out these holes so that you have a smooth movement here, which I obviously don't have here, and I don't have the drill here at the moment, so you have to use your imagination. The suspension here is going to move up and down. To adjust the ground clearance, you put in small washers of appropriate size on different side of the hub. So now it's rather tight in this hole, so I'm going to use my big pliers, polygrip. So, and let's see if I can untangle myself. So I'm pushing it through. So, okay, adjusting a little bit. We also need to have some springs. This seems to be fairly similar for all manufacturers. You can make your own if you want to, take from a ball pen and cut in the right length and so on. These are from X-Ray. The standard for X-Ray is F1 on the front, and see if we can put it on place here. So a little bit tricky. Okay, that didn't work. So Okay, sorry if you don't see everything, but getting this on place isn't 100% easy. So then it's on the right place. Adjusting. And there you go. Okay, maybe looking the right way. So, and we have a function, even though it's not 100% perfect, but there you go. So what we need to do now, well, we can assemble the wing. Maybe in the right way. Too short. So, and a nut on the other side. This nut is you can glue it on place with super glue, so it doesn't fall off. Well, it will not fall off because it's rubber underneath it. So, but when you are switching wings, you can switch wings on place then. So, and that one is going there, and with the skid plate underneath. This is actually giving strength to the whole the front, because what you have here is a rather weak place. Maybe like this. So it might break here. Having this this plate is stopping it from being forces down here, and this is holding it instead. So you see how it's done, and then of course with those M4 screws, M4 times 20 in this case, and you put the servo in here, and yeah, that's pretty much it. You see how it is made. I can show you the other car here. So I took part for this example. You see you have the servo put in here, a servo saver. Some people say you don't need to have a servo saver. I think that, well, it's nice to have it. And then I'm using some rods that I had laying around. This is Schumacher. This is from a really old car, and this is from a slightly newer. And you can use whatever you want there. Theoretically, we could put just a plastic piece there also, because the toe-in adjustments are not something I'm doing so often, and I don't think that others are doing it very often either. So that's how it's looking, and this is how it looks. Well, this car looks, and as you see, this one doesn't have the clamps around, so the cables are a big mess simply. It's not so much space underneath this, so you have to think a little bit how you're putting the cables, and preferably shortening them to the correct length. So, and just so that you will be happy, the guy that is going to have this car, I will put this on so he can see how it looks like. Almost ready to race. So thank you for watching this, and if you have any problems or thoughts about the assembly of this car, please send me a message, or preferably put it on the forum on Google+. There's a link from the Thingiverse page which have this one to the forum, and it's just to step in there and start talking. I'm extremely grateful if you are stating your opinion, even if it is a bad opinion. Please try to make it constructive. Try to find things that are bad that can be improved, or things that you have problems with. Tell me if it's going well. Post your pictures of your car. Send me a postcard. Well, anything is appreciated. Thank you for watching, and I hope that your assembly of your car is going to go well.